Being single is good.
Wow, that's so inspiring. Wow, what a wise dude.
Ross shed a few tears.
I miss
He
the
blamed
days
me.
when I had someone care about me.
He blamed me for losing his calculator and was gonna make me pay for it, and then he went, "Oh wait, it's in my gym bag." Whips it
Why
out.
do you have it in your gym bag?
I know, that's why I asked. I'm like, what are you doing with it in your gym bag?
According to
I told you I gave it to
if I
you.
made 3 free throws.
Alright, I gotta do this little video.
But if I miss all 10 of them, that means I have a negative.
The roller coaster goes down the first grade 8 times faster than it goes up the other side. The distance down is 100 feet more than the distance up. It takes 70 seconds to go up and 10 seconds to come down. What is the speed per second? So everything's in terms of seconds rather than miles per hour, so that's fine. If you're mixing and matching seconds and minutes, then you'd have to do some conversions. So chart, as usual. And here we go. And we have rate, time, and distance. And we say, reading the problem, it says the roller coaster goes up, and then the roller coaster goes down. So this would be up, and it would be down. Now, it says, let's look at the rate first. It goes down the first grade 8 times faster than it goes up the other side. So you're going to have 2 rates.
What?
If it goes up at R, it goes 8 times faster down. Therefore, right, if it's going 8 times faster, you would go 8R. Then time-wise, let's see if they give us anything in terms of times. It says it takes 70 seconds to go up. And since it's going to be in terms of seconds, you don't have to worry about any type of conversion. We don't want to convert it to minutes or anything like that. So 70 seconds to go up, and then 10 seconds to go down. Therefore, the rate up is 70R. The rate down is 80R. I mean the distance, not the rate. The distance up and then the distance down. Now, then, is the distances, that's the question, is the distance the same? Where we say, okay, the distance up equals the distance down. Is that, you might want to check the Pop-Tarts.
Oh.
Okay, they're gonna be hot. You're gonna have to get a Kleenex or something. So, we read it, it says though, the distance down is 100 feet more than the distance up. So if the distance down is 100 feet more than the distance up, okay, they're not equal. The distance down is 100 feet more than the distance up. Therefore, what do we have to do with the distance up? You have to add 100 to the distance up. And so you would state the distance up is 70R plus 100 is equal to the distance down, which was 80R. And then you can solve from there. Okay, so then the next one was 27, which was asked about, and 27 states, the auto race, one car travels 190 miles per hour while another travels 195 miles per hour. How long will it take the faster car to gain 2 laps on the slower car if the speedway track is 2.5 miles an hour long? All right, so here, 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 and here, here, rate, time, and distance. So we have 2 cars going on this, and it says it doesn't have like an east car or west car. It just says an auto race. One car travels 190, the other car travels 195. So you have 2 different cars. So maybe we just define it as like a fast car and then a slow car.
Ferrari.
Yeah, Ferrari and a
Honda Odyssey.
Honda Odyssey. Yeah, pick on my van. So what is the rate of the fast car? It says it's 195. What's the rate of the slow car? It is 190. So not actually too much difference. Now, time, it says how long will it take the fast car to gain 2 laps. So this doesn't tell us any amount of time. We know that they're, you know, if they're on a track here and it's like, okay, they start going, they both, like one car finishes quicker than the other car is coming around and it's not quite, you know, there, the other car has already passed. But they're traveling for the same amount of time. So in this case, we just say t and then we say t, right? And then we say 195 t for the distance, and then 190 t. So we are not going to ask the question, we're not going to say like the distance of the fast car equal to the distance of the slow car, because we know those distances won't equal, except right when they start. Right when they start, at time 0, their distance is equal, but as soon as they start going, the faster car is gaining more distance than the slower car. So this is not the equation we're going to use. They don't give us a total distance where it's like distance of the fast plus the distance of the slow is equal to, at least, they don't state like 200 miles or something. They don't ask us something like that. They don't give us that information. So we are going to use something along these lines, just a matter of which one we pick and then how we plug in the information, which was, if we read the information, it says, at what time, so that's why we have this unknown t, is it going to lap the other vehicle if the distance is I gotta read it here. Oh, the speedway track is 2.5 miles long. How long will it take? So, in that, the speedway track is 2.5 miles long. Oh, to gain 2 laps on it. Okay, so 2 laps. So, oranges, thank you. So, 2 laps. So, if 1 lap is 2.5 miles, right, 1 lap around, he wants to gain 2 laps around, so 2 laps around will be a total of 2.5 from 2.5 is a total of 5 miles. So what it's asking is, when is the distance of the faster car going to be 2 laps compared to the slower car? So the distances will not be equal, they're going to be different by 5 miles, because he's asking when is he going to get lapped twice. So the distance of the faster car equals the distance of the slower car. Remember, the slower car will have gone less than the faster car. The faster car will have traveled farther distance. So if we use this equation, we know the distances aren't equal, but what can I do to the slower car to make the distances equal? And that's where the slower car needs to add 5 miles to itself. So like 5 miles right there. So then the distance of the faster car is 195. T is equal to 190t plus the 5 miles. Again, it's 5 miles because each lap is 2.5 miles long. And the question is, when is the faster car going to be 2 laps ahead of the slower car, which means it's 5 miles ahead. If it's lapped at twice, it's going to be 5 miles ahead.